Assalamualaikum warahmatullahi wabarakatuh. We are from Group 7. In this project, we will present about Truss Bridge. My name is Nur Maizatul Husna binti Zulkifli. My other members are Nurul Nadia binti Mak Jusuf, Nur Shazana binti Ma'aruf, Nur Farina binti Idris, and the last one is Izzatul Aisyah binti Mak Saleh. My name is Nur Maizatul Husna binti Zulkifli, metric numbers AF200101. So for the introduction, this project demonstrates our ability and originality in applying what we learn in structure analysis. In civil engineering, trusses are conventional structure made up of three or more components that are pinned or hinged together at one point. There are no continuous members through the joint. The structure of this style of bridge is considered to be the most stable, therefore strict element usually from a triangle unit.
Assalamualaikum, my name is Nur Farina binti Idris and I'm going to present for the part 1, layout and design. Okay, our group chose Warren Truss Bridge. Okay, Warren Truss Bridge is a patent by James Warren in 1848 in England. Why we selected this bridge is because ability to distribute load evenly across a number of different members, and low deflections, lightning concept, and ease for constructions, especially for the road constructions. Most basic yet effective design. For the advantage is the use of quadrilateral triangles with each have the same length, and to distribute the weight of the bridge, the Warren Truss employs equilateral triangle. With reasons, we calculate the degree of determinacy of the Warren Truss bridge. You can see that M is a member and R is the reactions. We calculate M. We get members 21 and reactions is 3, and we include the value into M plus R equal to 2J, and we get
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Izzatul Aisyah binti Mak Saleh. I will proceed my presentation for part 2, data analysis. We go through for manual calculation. First, we need to determine the support ration. So we get the VG and VA is equal to 8.5 kN to hour, while HA equal to 0. So next, to determine the internal force, we use the alternative method, which is the easiest one. The right figure is the internal force that we get from the alternative method. Next, determine the deflection by using virtual work method. First, we apply 1 unit to downward at the center of thrust. After that, use the same concept as before to get the internal force, which is alternative method. From the result, we can come up with this table to get the total of FUL. We assume the modulus elasticity and cross-sectional area are constant and use formula summation of FUL divide AE to get the deflection. So we get the deflection is 0.198 meter. This is comparison data between manual data and software data. The value for reaction at support and internal force are same, but the deflection is different 0.198 meter.
Assalamualaikum, my name is Nur Shazana binti Ma'ruf and my matrix number is AF200065. So, for discussion, the ability of a structure to endure its intended loading without fracture, distortion, or fatigue is known as structural integrity. It is a design concept that is usually applied in engineering to create objects that will fulfill their intended functions and last for a specified amount of time. An engineer must first analyze a material's mechanical qualities such as toughness, strength, width, hardness, and elasticity before determining the size and form required for the material to sustain the intended load for a lengthy period of time. Furthermore, the integrity of each component in any load-bearing structure must correspond to its specific application. The bolts that hold the bridge supports together must have a high yield strength, while the bolts that hold them together must have a good shear and tensile strength. Spring elasticity is important, but lathe tooling requires a lot of stiffness. The entire structure must be capable of supporting its load without its weakest link failing, as this might cause additional stress on the other structural sections, leading to cascading failure. A safety factor is used during the design process to lower the risk of bridge failure. A safety factor is a measurement of a structure's ability to sustain loads greater than those for which it was built. The majority of truss bridges are built with a safety factor of greater than 1.6. According to H2, evaluation techniques for bridges are frequently listed for lighter traffic loads than the actual load capacity, which can be determined by more sensible evaluation procedures.
My name is Nurul Nadia binti Majuso and my matrix number is AF200097. As a conclusion, after completing this project, we learned about the types of truss bridge, how to design the bridge, types of possible loads, and how to calculate ultimate load combinations. We already know that in our daily lives, bridge play an important role. They are important components of cities and roadways between populations of people. Designing structures such as building and bridge is a huge responsibility for an engineer because they should be ready for any risk. So in order to obtain the acceptable, safe, efficient, cost-effective and good design, we must first fully comprehend the situation.